Okay, thanks CSAP for having us here. Okay, hang on. There we go. So Cindy and I are here to talk to you today about one of the special projects that CSAP has funded, and it's in regards to Peat, working in Peat, and looking at the issues that practitioners have with investigations in Peat, and from soil sampling, analytical methodologies, risk assessment, and just interpretation in general. So we'll look at definitions of and characteristics of peat, peat analysis and biases, and regulatory framework and issues with peat assessment, review of analytical limitations, and some of the great research and studies that have been ongoing here in BC. And we'll leave you with some recommendations. So we've got some that are interim quick fix for practitioners, and also some longer-term recommendations that we want to put forth to BCMOE for consideration. And you know, the intent of this is to be a bit more comfortable with doing investigations in peat media. I know there are a lot of issues with it, and so that we can successfully assess and not necessarily remediate all this precious peat environment. All right, so in regards to definitions, the BC MOE Procedure 8 has a definition for organic soils. So it's soils containing at least 30% by weight, commonly known as peat, muck or bog soils. And soils are defined, one of the definitions is to include unconsolidated materials or organic material. Tarnoke, who's peat specialist in Canada, he defined peatland, such as muskeg, which is quite common up in the northeast BC, as containing more than 40 centimeters of peat accumulation on which organic soils develop. So here's a table of peat characteristics compared to mineral soils. You know, often we use Fraser River sand. It's the basis of a lot of the modeling that used by MOE. So you can see the moisture content, water retention in peat. It can be up to 20 times its weight in water. And also the pH is quite lower in peat materials. And so when you look at all these characteristics, you kind of wonder about the natural definition of peat. Does it constitute a soil? It is considered a soil in the BC regulatory regime. But maybe we should possibly look at it as a matrix of organics and water, more akin to tissue. So we should give consideration as its own media potentially, or a subset media of soil. So some of the issues and biases encountered by practitioners, one is like field sampling of peat. So right now there's no current prescribed methodology for sampling, and which can lead to issues, especially because of its high water content. Also, there's naturally occurring background concentrations. Based on practitioners' investigations in peat, we've encountered that often arsenic, cadmium, chromium, selenium, and titanium concentrations often exceed Protocol 4 or CSR standards in both like on-site as well as background conditions in peat. Detectable biogenic toluene is also common to be observed in background areas in peat. Other biases include laboratory detection limits, blanks, and duplicates. So we often see elevated detection limits. They're not uncommon in peat samples, but they can be an issue when you're looking at low standards, such as for BTEX. And there is no standard reference material for peat because it is a very heterogeneous material on a given site. You can have like a stick-like peat versus sages and fens and soil standards versus bioavailability. So, for example, in EPH, soil standards assume that reported concentrations are fully bioavailable, but in higher organic soils, they absorb portions of the EPH, making it less bioavailable for uptake by living organisms. So, for example, EPH standards may overestimate the true risk in peat. Cindy is going to talk a little bit more about that later on in the presentation.
So where does peat fit into the regulatory framework for numeric standards? So generally, for human receptors, the numeric standards are based on tox values from US EPA and Health Canada tox data. And generally, the ecological receptors are based on a calculation for an effects concentration depending on land use. And if you want to look at the details, we have had many presentations on the omnibus derivation of standards. So that's, you can go back and look at that. But it's all based on tox values, and that's where they want to make our standards tox-based. We also have the site-specific soil standard that you can derive using Protocol 2 and the CIS model. So many of the tox databases, they're mainly based on mineral soil data and not representative of the peat ecosystem. And on peat, I mean muskeg, peat, high organic materials. In the site-specific soil standard recalculation, you're allowed to change some of the default values, and for the FOC value, that's a fraction of organic content, it's 0.06% in the CIS model, and you can vary it up to 2%, which is great, but it is much less than a peat FOC, which can be up to 30%. For the risk standards, we have the Technical Guidance 7 that recommends preferentially to use the US EPA eco-SSL values that are derived. So if you go to that database, you can, it's not sorted for organic material or percent organic, but you can use the word organic in your within your search, and it'll pull up the tox values from using a higher organic material. There's very few studies with organic content above 6% for soil. And actually in the US EPA document, it states, there's a quote right there about the eco-SSLs for plants and invertebrates, that the organic matter content should be less than and equal to 10%. And it says it might not be applicable for certain soils. So that's kind of the context of peat. There is some bright lights. There is some research going on. University of Waterloo has done bench scale tests using spiked crude oil on peat soils. And one of the problems that they found was that the standard ecological test organisms, the invertebrates, they didn't thrive in the control samples. They didn't thrive in a peat environment. So it wasn't very successful to find out how it thrived in a impacted environment because it didn't thrive in the peat. They had made some recommendations to Environment Canada to use alternate test organisms. Also, Bright and Addison, they did some studies for a new chloride standard in peat, and it was between 600 and 1,500 milligrams per liter. So there is some work being done on peat to advance different standards.
One of the things we also did was look at analytical limitations and some of the studies and research that's ongoing for these three particular parameter groups. So it's quite detailed here, but to summarize it, for metals, it was there's some issues with respect to the lab equipment being used, and so there's some preference for one over the other, the ICP-MS rather than the SOM. Also, the methodology, so use of tissue and vegetation method was recommended. With respect to hydrocarbons, we know that we have here in BC the EPH silica gel cleanup, which helps to remove some of the organics and to to reduce the falsely elevated EPH concentrations. However, what we've kind of surmised by asking practitioners and the labs is that there are also some limitations with the silica gel method, and probably could use some review and updating to that methodology. With respect to salinity, I think there is strong evidence to support that we should perhaps for peat, because it is miscible in water, to look at a milligram per liter unit to assess salt contamination instead of the micrograms per gram, because when you do the conversion of dry weight, the concentrations can be up to 20 times greater. One of the things that's also done across Canada is the biogenic interference calculation index. I won't go into much detail about it here. Suffice it to say it's a mathematical approach to resolve false petroleum hydrocarbon compound exceedances in organic materials. It focuses specifically on the CCME Canadian Wine Standards F3 fraction, which is equivalent to our HEPH. It's currently been adopted by Alberta Environment as a screening tool. There's the formula for it. And so basically, if you have less than 10%, it kind of identifies that it's a false PHC exceedance. Greater than 10% kind of identifies that, yes, it is actually a true exceedance and that it is contamination. So we looked a little bit at it, and perhaps with some slight adjustments to the BIC index calculation, would allow it to be applied here in BC for EPH methods to identify false exceedances. And it might be a standard application of an adapted BIC index could quantitatively identify samples that warrant a silica gel cleanup. The BIC index was created by Dr. Francine Kelly-Hooper through her 7-year PhD study. All right, so some interim quick fix for practitioners. What do you do now? Yeah, okay. So some of our recommendations, as we touched upon in the presentation, so was one of them is to request from labs to complete an extra concentration step to obtain a lower detection limit for peat samples for low standard parameters. So this is not a standard lab approach, but if it can be done for high moisture content soils, you just need to ask the lab for that. In regards to peat sample collection, we have heard that some practitioners intentionally squeeze out the water from a sample before putting it into the jar. We got to remember that the water component of peat is valuable, and it's part of peat material. It's definitely critical for salinity, which is miscible in water, so you squeeze out all that water, and lo and behold, you have no contamination. And another thing that we can do is use a screening level risk assessment and multiple lines of evidence when presenting our rationale for interpretation of anomalous concentrations in peat, including wet weight concentration, doing that background assessment in naturally occurring undisturbed areas, or chromatogram reviews for biogenic peaks. Some additional ones is to obtain background releases for detectable metals greater than the P4 concentrations, particularly one of them is arsenic in the Northeast BC. Also, if you're working on a site that entertains both provincial and regulatory regimes apply, you might want to consider the BIC index calculation for that F3 to see if there is a true exceedance that exists or not. And also, as Cindy mentioned, using the higher FOC value for peat when using your Protocol 2 SST calculations. Again, it's only 2%, but it's better than the 0.6, moving towards that 30%.
And we also have provided some longer-term or short-term recommendations for BC MOE that we can move forward on the regulatory and the sampling. So for field methodology, if we could provide some standardized peat sample collection methodology, that might help in the collection of the peat samples or high organic samples. For the standards, if we could move towards identifying peat either as its own media or a subcategory of soil, therefore you can allow for specific standards to be derived for the peat media based on their own specific and special characteristics, toxicological characterization. So that would involve reevaluating the soil standards based on the tox data and using appropriate soil invertebrates specific to the peat environment. I would believe that that would give us some higher standards with more representative risks. Deriving salt standards as milligram per liter rather than milligrams per kilograms, and I think we're moving towards that one right now. That would eliminate the variability across the soil types due to the water holding capacity. There's a lot of work analytically, so we recommend reviewing the analytical lab methods for peat material and looking at digesting the peat samples using the tissue and vegetation method, not sieving to 2 millimeters because a lot of that organic material is greater than 2 millimeters, and keep that in the analysis. And then using an ICP-MS collision component to the ICP-MS for metals analysis. There's a collision cell that they use that gives you better values than the standard ICP-MS. Allowing for as received saturated paste methodology, and reviewing and updating the silica gel methodology, maybe completing a multi-lab study and seeing the variability. For peat samples, you're allowed to do one silica gel treatment, but for peat samples, maybe there's either a longer silica gel column or maybe doing 2 passes because of the high organic content in those soils. So there's room for research there. For the regulatory, currently, if you're using Protocol 2, you are allowed to derive a new soil standard for your site, but if you have different soils on the site, you have to take the more conservative soil as your standard. And so we're recommending that if you have a site with peat, that you're allowed to have 2 different standards, similar to having 2 different standards with varying pH ranges for some of the metals. We also recommend completing new background peat concentrations for the Protocol 4, specific for peat. There is some, that we know of, there are some peat soil samples that have been collected that could be used for this database. So it's a matter of just collating that and maybe using some of our data that we've collected over the years to back that or include in that data set. And providing more guidance to when silica gel cleanup can be used. So this is a real quick snapshot of our research, and we try to cover off the sampling and the analytical and the regulatory aspects of it. And I know that we've gone through it quite quickly, but our report is going to be finalized shortly, and it'll be available for you to review. And we've dealt with peat, Michelle and I, for many years, and would love to know about some of your issues if we haven't covered them, and other considerations with peat in your practice area. Thanks.
Hi, Michelle. Thanks for the presentation. I was looking at a remote mountainside where I'm not sure if it was peat, but I think it was organics. And I'm curious about your particular reference to the wet weight concentrations. The ministry standards are all based on dry weight, right?
Yes. Yeah.
So we can't really use wet weight concentrations. And I was just comparing the 2 methods of calculations. The numbers vary hugely.
They do, yeah.
Right? 5 to 10,000 micrograms per gram, right?
Absolutely. And so, again, it's perhaps part of your discussion as one of the lines of evidence is to kind of show the wet weight concentrations compared to the dry weight, and using it as part of your
But has there been any example of using that argument to get a COC?
Not to my knowledge. But I know.
Using the lines of evidence, approach to not applying the soil standards to the peat?
No.
Yeah, Peggy, the standards are based on dry weight, right? So I'm even wondering how we can use wet weight as a line of evidence.
You know, I'm going to defer to Glenn because this is a question that Glenn's been faced with many times over. Sorry, Glenn, to put you on the spot, but I think this is a question for you.
No worries. So one of the things that we are working with BC UPEC with Doug Bright and various other members, Lavinia knows more about this than me. She's our new lead on BC UPEC stuff, but we are working towards potentially having a series of options to deal with organically rich soils that include potentially setting a new set of soil standards specifically to peat or muskegee soils. So recognizing that at least as a very different soil than we're typically used to using, all the way to allowing for some substances at least, for example, salt, moving to a wet weight basis, milligram per liter standard for that particular type of soil. But that is probably at least a year, maybe 2 years into the future before that work is wrapped up. So this is very useful. And I know that I believe Michelle and Sydney have been in touch with Doug Bright. So hopefully you guys are working together to bring your results to his attention and vice versa. One of the things that we did want to ensure from a toxicological point of view is that any standard that was going to be relevant, strictly relevant to muskeg or peat, was based on appropriate invertebrate toxicology. So part of the deal that we originally had with BC UPEC was to make sure that we had some in situ Northeast BC toxicological studies done, where we spike some peat soils and collect some ECX data for it. Unfortunately, that part of the project fell through because Doug Bright was unable to find a site that would be willing to undertake that type of experimentation, even though the ministry had assured any owner of an oil and gas site that wanted to participate in that we would not come after them and try to make them clean up the site. So we'd give them an exemption essentially for that kind of work. At any rate, he couldn't find one, and Crown Lands didn't have one to offer either. So what we're now doing as part of that project is we're considering getting essentially spike lab examples, lab bioassays, using, unfortunately, more standardized invertebrate receptors, but at least trying to match them better to what is typically seen in the north. So this is a very timely project. The ministry is very aware of the issue. We are working towards finding something that's more sensible.
Hi, I just wanted to mention that the new draft P2 coming out, we have increased that FOC limit to 5%, which is hopefully giving some more relief.
Great.
Yeah, I think that's it. We'll talk more about P2 later in the afternoon.
I think that's...
Okay, great. Thanks. Thank you.
you.